Alrighty, welcome. So today we're going to be looking at the volume of prisms. So volume is a measurement of how much space is inside a three-dimensional object. So you imagine that you've got something and you want to fill it up with something like water, where you want to fill up every single bit inside it. That's the purpose of volume. And so we measure it in cubic units, or if we're doing capacity, which we'll look at a little bit later. You're probably more familiar with things like milliliters, liters, kiloliters, megaliters, those sorts of units. However, in order to actually calculate it, we tend to use the volume units, which are cubic millimeters, cubic centimeters, cubic meters, and cubic kilometers for very large quantities. If you remember back to the square meter video, well, a cubic millimeter is 1 millimeter by 1 millimeter by 1 millimeter. So that would be a cubic millimeter. A cubic centimeter would be a centimeter by a centimeter by a centimeter. A cubic meter would be 100 square meters. 100 centimeters by 100 centimeters by 100 centimeters. So very, very large. And then for a cubic kilometer, we're looking at hugely large, right? So these are the different sized shapes that we are looking at, okay? So when we talk about a cubic meter is not a small unit of measurement. In fact, it is an extremely large unit of measurement. Or a cubic kilometer even is even more gargantuan. So let's just learn the conversions, alrighty? So 10, 100, 1,000 is the standard, and because it's cubed, it's going to be to the power of 3. Now, to get from cubic millimeters to centimeters, it'll be divide, and then to get back, it'll be times, divide, times, times, times. Okay, so this is our little conversion chart. Now, if you remember 10, 100, and 1,000, you can learn all of the conversion rates between cubic millimeters and cubic kilometers for absolutely all of them. So, makes life quite easy. So, what is a prism then? Well, a prism is just a shape, any shape, in which the bottom of it, let's call it the base, is the same as the top. Alrighty? That is what a prism is. So, any shape in which its bottom and the top are the same. So, that would have been a rectangular-based one. You can have a triangular-based prism. It's like a Toblerone box, but this one I've stood up on its side. And in fact, to draw them, you just draw two of the same shapes. So for example, if I wanted to draw a parallelogram-based one, well, I can just draw two parallelograms. Again, try to make them as identical as possible. And then you can just connect the dots. If you want to go back and turn some of them into dotted lines, certainly adds the 3D perspective on it. Anyway, so these are some of the shapes that we'll be looking at. So let's see how we can calculate the volume. And we have this weird swimming pool sort of thing, and we know that the area of the top. And we also know this height between the two. Well, the volume of this shape, well, it's just going to be the area times the height. So just in terms of specificity, it's really an area calculation and then multiplied by whatever the height is. But just make sure that this is the area of the base. And for it to be the base, it needs to be the same top and bottom. Alrighty, so there's our rule. Let's have a look at a couple. Alrighty. So let's have a look at this first shape. So this is a triangular-based prism. How do I know it's a triangular-based prism? Well, because the triangle is the thing that these two have in common. The rectangle on the bottom actually doesn't have a match on the top, because at the top it's just a line, which doesn't actually match. So this is a triangular-based prism. So to work out the volume is equal to area times height. And in this particular case, the area is equal to a half BH, where these two H's are in fact different. So let's just ignore the rest of it and just look at the triangle. So the triangle has a base of 16 centimeters and its height is 18 centimeters. So this is our h for the triangle. Alrighty, so it's going to be half times 16 times 8, which is equal to 64 centimeters squared, right? Because it's an area calculation. And the height of the prism, it's called HP, is going to be 10. Why? Because that's the actual distance between these two triangles. It's 10 centimeters. So that's going to be our height. So volume is equal to 64, the area, times the height, which is 10, which is 640. And since all of our units were in centimeters, the answer is going to be in cubic centimeters, which is written centimeters cubed, but remember we say the cubic first. Let's have a look at a second one. Alrighty, let's have a look at this shape. Well, this shape, the base, once again, isn't going to be the rectangle that's actually on the bottom. It's actually going to be this L shape here. That's going to be the base. So step one, we need to actually work out the area of the base. And so we know it's a prism because it's got a consistent cross section. So it's got that base, top and bottom. Obviously it's going front to back, but we can still see that that works just fine. But the more interesting part is actually how do we calculate the area? Well, in this case, we need to break the area into two pieces. We could break it that way, or we could break it this way. It doesn't actually make a difference. So in this particular case, I'm going to break it down this way. So I'm going to have area 1, area 2. Area 1 plus area 2. Now, thankfully, both of these are just length times width. So LW plus LW. And now we just need to work out the dimensions. So for the first one, we can see that it is a 13 by 3 meter, because this is the same as that. So it's a 13 by 3. And for the second shape, well, this whole line here is 12. 3 of it's been taken off. So that means the remainder part must be 9 meters. And its height is 4 meters. So this second part is going to be 9 times 4, which gives us a total area of 75 square meters. So that's the area of the base, but I'm looking for the volume, so now I need to multiply it by the height. And the height in this particular case is going to be this 4 meters here, because that is the distance separating the two identical faces. So we're going to get 75 times 4 meters, which is equal to 300 cubic meters. Alrighty, so that is how to do volume of a prism. See you next time. Bye.